Welcome trig warriors to our video on reciprocal functions. The cosecant, secant, and cotangent. And I included this cute little meme here because I want you to take a second to remember what the graph of sine, cosine, and tangent look like. Okay, remember that. Cotangent is one of the ones we're going to look at. Look at the relationship. We'll see that soon. Alright, and poor SpongeBob apparently is struggling with his trig. Okay. Cosine, sine, and tangent have reciprocals. And you already know what a reciprocal is. If we have a value a, for example, an algebraic value a, the reciprocal would be when you flip it over and get 1 over a. Cosine and secant, that's the name of the reciprocal. And then sine and cosecant, those are reciprocals. And then tangent is reciprocal to cotangent. So you see that relationship down here. Cosecant equals 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. One quick way to remember this is if you write down sine, cosine, and tangent, you can write cosecant, and then going straight down, the C, and then straight down, it's cosecant again. SC. So that's secant, goes with cosine, and cotangent goes with tangent. That one's easy to remember. Just remember that cosine doesn't have a co on its reciprocal function. It has just secant. Okay, and if these things are true right here, here, and here, it's important to also recognize that sine of theta would be 1 over cosecant theta. And that's going to become important when we start verifying trig identities. Okay. Now, how do we find unit circle values for our different reciprocal functions from the unit circle? Well, there's a couple different things you can do. If you have the unit circle, and we know with our unit circle we have x and y, x being the sine, y being the cosine, I could, with my unit circle, find 1 over y, which is 1 over the sine, and that would give me cosecant. I could find 1 over x, which is 1 over the cosine, to get secant, and I could find x over y instead of y over x to find the cotangent. So we're going to do that with these 3 examples here. Okay, the cosecant of pi over 3. Well, the first thing I'm going to do is I'm going to sketch my own little unit circle. And notice that it's not very symmetrical, but it's close enough. And I'm going to go ahead and draw pi over 3, which isn't perfect, but again, close enough. And I want to think about the ordered pair that's there on the unit circle. The sine is the y, and that's the height above the x-axis, so that's root 3 over 2. And the cosine is 1/2. So if I want to find the cosecant of pi over 3, I want the reciprocal of the sine. So that's going to equal 2 over root 3, which then of course has to be rationalized, that denominator. So multiply by root 3 over root 3, which is going to give you 2 root 3 over 3. And that is the cosecant of pi over 3. Okay? Now I want to go ahead and take and find the value for the cotangent of negative 5 pi over 4. So, I'm going to go ahead and delete this. Okay, so bye-bye now. There we go. Okay, cotangent, we'll do it in red, of negative pi over 4. Or negative 5 pi over 4. Draw a picture. Unit circle. Negative 5 pi over 4. Well, if I start traveling around the unit circle in the negative direction, there's 4/4 and then 1 more fourth. So I'm looking at this angle right here. And go ahead and find your sine and your cosine there. Well, they're both root 2 over 2. It's just that the sine is positive and the cosine right there is negative. Now, I know that I'm finding cotangent, which means I want to think about the tangent. Or I can use my rule up here. But remember, it's more important to understand than to memorize. So this may require memorization, whereas understanding that cotangent and tangent are reciprocals, that doesn't require memorization, it requires understanding. So the tangent of negative 5 pi over 4 would involve putting sine over cosine. So root 2 over 2 over negative root 2 over 2, which would give me a negative 1. And guys, the reciprocal of negative 1 is still negative 1. So our cotangent of negative 5 pi over 4 is going to be negative 1. Okay? And lastly, the secant of 3 pi. Oh, I'm not going to be able to do that. Okay. let's try something different. Go away, and then you guys go away too. Oh, and you too. Go on. All right. We'll do this one in blue. Secant of 3 pi. All right, again, unit circle. Well, once around the circle is 2 pi, and then one more way around. So this is where we're at right here. So we're talking about this angle. And again, we went around to there. Well, I want to find, because it's secant, I want to find the cosine of 3 pi, which is -1. And again, the reciprocal of -1 is still -1. Okay, so that one was not super complicated at all. All right, use the unit circle at the right to find cotangent n, cosecant n, and secant of n. So if this is 3/5 right here is the angle, all I can say about the cotangent of n is that it's going to be equal to, let's do this in a different color, let's use green. It's going to be equal to 1 over the tangent of n, which in this case, it appears they're trying to say is 3/5. That would equal the cotangent of n. To get the cosecant of n, we'd have to have 1 over the sine of 3/5. And then finally, to find the secant of n, we'd have 1 over the cosine of 3/5. And I think that was the very simple question they were asking right there. What are the graphs of y equals sine x and y equals cosecant x in the interval from 0 to 2 pi? Well, the book beautifully made us a table. So take a look at this beautiful table. So we have our x values in radians all the way to 2 pi by sixths, actually, if you break it all the way up by sixths. And then we have our sine values as decimals, just so we can draw a sketch of the curve, and you can see that here. Well, let's think about what we have. Well, if the sine is 0, that means the cosecant is undefined. So the cosecant at 0 is undefined because you can't take a reciprocal of the number 0. You'd have 1 over 0, which we can't have. That's just undefined. So at those places, at 0, right here, at pi, which is another place where the sign is 0, and then at 2 pi, you see that here and here, you get asymptotes, good old asymptotes. So these lines right here are asymptotes because, right at the bottom of the iPad, it doesn't want to let me write on it, asymptotes because that's where that function is undefined. And if you notice then, what we learned about inverse function is that you get mirror imaging. Now, we are used to thinking about mirror imaging over the line y equals x, and that's not really what we have here because we have a situation where you've got 2 different scales. You're counting by radians here, really, and you're counting by 1s and 2s, so just by numbers here. So what we get is we get these parabola-shaped parts to the graph, and it would keep going, guys, like so. So what you're going to do when you want to graph cosecant is you're going to graph sine lightly, and whatever bells and whistles are on your function, so if it was cosecant and they had done something to x, you're going to graph that sine with those specific numbers. You're going to put asymptotes where it's equal to 0, and then you're going to get these little curve up, curve down, and it's vertex to vertex. So the value is the same where it's 1, because the reciprocal of 1, look, the reciprocal of 1 is 1, and the reciprocal of -1 is -1. Let's take a look at what it looks like when you graph secant and when you graph cotangent. Here we have the graph of y equals the cosine of x. So, as we did with sine and cosecant, now we're graphing secant. So I'm going to put y equals secant x. Everywhere that you see a value of 0, draw an asymptote. Whoa, sorry. It's very hard to draw a straight line on an iPad, guys. And then here again at 3 pi over 2. So it's at pi over 2 and 3 pi over 2 for this particular function. And then what you're going to do is where you see that peak of the cosine graph, you're going to go ahead and draw out like so. Now here's one way you can get a more specific point that you know is going to be on this graph. At the value 3 pi over 4. So at 3 pi, so here's Yeah, 3/4 pi, which is right halfway in between here. At this point, the cosine is -1/2. So the reciprocal of -1/2, so the cosine of 3 pi over 4 is -1/2. That means that the secant of 3 pi over 4 has to equal -2. So I know that for this value, I know that I have this in that general shape because I know that this has to be -2 right here. So that gives you kind of a benchmark to make your graphs a little bit more precise. Okay, a little bit. So that would be here for this one, and then so on. And I could keep that going to the right and to the left forever. But this constitutes one full period right here. Okay, or this whole thing here. One full period. Okay? Here we have a moderately poorly drawn graph of the tangent of x. It should be curvier than this, but I am really struggling to get the iPad to let me write nicely with a stylus. So it is what it is, guys. It's going to have to just be the right shape in our heads here. So cotangent. Let's think about what's going on here for cotangent. Well, first of all, the asymptotes are not going to be in the same places. The asymptotes are going to be where tangent has a value of 0. So that means this is going to be an asymptote for cotangent. And the y-axis is going to be an asymptote for cotangent. And then again over here at -pi is going to be an asymptote for cotangent. And then let's think reciprocal, right? Reciprocal. Well, if we look at the reciprocal of 1, that's 1. But what you will find is that the shape of cotangent runs downhill. Let's think about the cotangent at the reciprocal, at the asymptotes for tangent. So the cotangent, let's get the cotangent of pi over 2. Well, what's the cotangent of pi over 2? Well, the sine at pi over 2 is pi over 2 up here. Hello, not pi over 4, Mr. Compt, get it together. At pi over 2, the sine is +1, so it's cosine over sine, so it's 0 over -1. So at the asymptotes for tangent, you get zeros for cotangent. You get zeros for cotangent. You get the same sine values, SIGN, sine values, at 1 and -1, because the reciprocal of 1 is 1 and the reciprocal of -1 is 1. So you get a graph that runs downhill. Oh, wow, that one was so perfect. Let's see if I can do that again. I bet I can't, guys. I bet I can't, but I'm going to try. All right. Oh, that's not bad, not bad. All right, and that is the graph of cotangent. Now remember, we can put bells and whistles on our functions all we want, and we do get a different shape. We can stretch it, we can shrink it, we can translate it, but you've got the general idea. See you guys in class.